Part 4. We've got non-rigid transformations. You might ask, what is a non-rigid transformation?
Mr. Klein, what is a non-rigid transformation?
Once again, another fantastic question. Well, a rigid transformation is what we've learned about already. Those are your horizontal shifts, your vertical shifts, and your reflections. And that's because your shape goes unchanged. So whenever you have a rigid transformation, that is when your graph is unchanged. If you have a non-rigid transformation, well, that is where you have a distortion, what we call a stretch or a shrink. So when you're looking at your stretches or your shrinks, you also have to figure out if it is a horizontal or a vertical stretch or shrink. It will make a difference because if you're doing a horizontal, then you got to be thinking, you have to do the opposite of what you read if you're dealing with your x values. So let's try example 5 here, and what we're first going to do is we're going to compare the graphs of each function. So if we have f of x equals x squared, all right, f of x equals x squared, that is a parabola centered at your origin, opening up. Well, what you have is you have a 4 out front. That is in front of your function. It is not a part of your function, or it's not inside your x squared. So that means this is going to be a vertical stretch. Remember, if it is vertical, it is just what you see. So here you're going to have a vertical stretch by 4. B, you have a 1/4 out here in the front. Well, that's not going to be a stretch because if you have a number that is less than 1, that is going to be a shrink. But because it is out in front of your function, it is going to be a vertical shrink by 1/4. So you need to make sure that you state both, whether it's horizontal or vertical, and whether it's a stretch or a shrink each time you do a problem like this when you're comparing graphs.